We talked about mean in the multivariate setup. It is the most popular measure of central tendency. In this video, we shall learn about a multivariate measure of dispersion. Measuring dispersion in a multivariate setup is tricky. In a univariate setup, dispersion is all about how spread out the points are along a line. Either they are scattered much or they are scattered very tightly. Accordingly, we could measure univariate dispersion using just a single number like the variance. But even for a bivariate case, the spread of the points depends on the direction that you are looking from. If you look along this direction, then the spread is lot. If you look along this direction, then the spread is much smaller. As there are infinitely many directions, it is not readily obvious how to measure multivariate dispersion. A little linear algebra comes to our rescue here. When we look at the points along a certain direction, this is basically taking a linear combination of the variables. For example, if we take 2x plus 3y, then what we do is this: we first collect the coefficients 2 and 3 into a vector 2, 3, which is like an arrow, and consider the line along that arrow. That little arrow here represents the vector 2, 3, and we have taken the line. Now we project all the points perpendicularly on this line, and as a result we get the foots of the perpendicular, which is like a univariate data, and we can compute its variance. Now you may need to spend some time to understand why this is effectively same as taking this linear combination. Now, in order to capture the spread along all possible directions, we do not just need to take this specific vector 2, 3, but a generic vector, say a, b, and project all the points onto that line. And then we compute the variance of the univariate projected values along the line. This amounts to basically computing variance of ax plus by, which is a squared times variance of x plus 2b times covariance of 2ab times covariance of xy plus b squared times variance of y. Now this may be very neatly packed into a quadratic form like this: AB, then a real symmetric matrix, then AB written as a column. This real symmetric matrix thus captures the dispersion along every possible direction. Once you know this, if I tell you any such direction, you can immediately tell me, using this quadratic form, the scatter along that direction. This matrix is called the dispersion matrix of the random vector and is the most popular measure of multivariate dispersion. If we have a p-dimensional random vector x1 to xp, then its dispersion matrix is a p by p matrix where the ijth entry is given by covariance between xi and xj. Now this method works both for a probability distribution as well as for computation based on samples. Let's see the computation of this based on a sample using the R software. We are using the same data set that we used earlier, 3 variables, 3 cases, and we load the data as before, my dat equal to etc. So I have loaded it. Now the function is very simple, just call, then the entire data frame, and it will find out the dispersion matrix or the covariance matrix, and you get this. So this number is covariance between x and x, which means it's the variance of x. Similarly, this is the covariance between x and y, which is same as covariance between y and x. Similarly, this is covariance between y and z, and so on. So because we have got 3 variables, so you have got a 3 by 3 matrix. It is as simple as that.